Hi dear students and viewers, in this video we are going to discuss about the another important 4 marks question in the chapter of oscillations, that is derive the expressions for displacement and velocity and acceleration of a particle which is in simple harmonic motion. The question should be like this: derive the expression for displacement, velocity and acceleration of a particle executes SHM. That is the question, children. This is the very important question. This topic will be helpful to the another long answer question in the same chapter. Okay, that's why watch very carefully, children. Here, this is the one circle of radius capital R. Radius what is capital R. On that one particle is there. I am saying that is the particle. Clear? Here there are two diameters. We are saying some x dash is one diameter, and y dash is the another diameter. This is the another diameter, y dash. The particle P is moving along the circular path like this. Clear? When it is moving like the in the path of circular S, then its motion should be considered as simple harmonic motion, because we can explain the motion of the particle with respect of these two diameters x dash and y dash. For example, if the particle is here, now this is the position of the particle on the diameter y dash. If it is here and this is the position now, the same particle will come to here. Now it is the particle S, and if it is here like this, that means what? While it is in circular path, when we observed its motion with respect of y dash, it is the main position. It is moving to and fro, motion is there. It should be when the particle is in the semicircular of top one, then obviously the projection of the particle should be from O to Y. When in this part, when it is in secondary circle, second semicircle, then the projection of the particle should be along the OY dash. That means what? If the origin is the midpoint or mean position, from the above tree, that one, and below that one, the particle will move like this. When it is in one complete rotation, along the diameter, it is moving up, down like that. If we can consider the x axis, then the particle should be moves like this. So that means what? When it is in the circular motion, it is also considered as the SHM. Why? Because with respect of two diameters x dash, y dash, these are two are mutually perpendicular. Even though they are in mutual perpendicular, the combination of motion of the particle with respect of those two diameters will use the SHM. Clear? That's simply what we are saying now. Derive the expression for displacement, velocity and acceleration of the particle executes the SHM. Generally what we can feel when the particle is moving along the circular path, we will simply that there is rotatory motion. So but when we can go for the x dash and y dash, by taking them into the reference, we will decide that the particle motion is nothing but simple harmonic motion. Clear, children? When it is in simple harmonic motion, how we can derive the expression for velocity, displacement, acceleration? Let us see now. Let us consider P is the particle that should be moves along the circular path. When it is at this position, we have to draw the two normal lines. One is onto the x dash and one is onto the y dash. So here this is the thing, but it is parallel to the y axis. So I am going to write here, this is the y, and this is parallel to the x. We can write that is the x. Now these two are the angles. Clear, children? So when it is moves along the circular path, the angular displacement should be given by the formula angular velocity omega is equals to what you have to write? Simply angular velocity is equals to omega is equals to what, right? Angular displacement by time. Angular displacement by time. Simply we'll write omega is equals to theta by t, and theta is equals to what, right? Omega t. Theta is equals to omega t, we can write, children. So in the diagram, in figure, we will take triangle OPN. OPN. From that, what, right, children? Sin theta is equals to what I would write? Sin theta means what, right? Opposite side by hypotenuse. Here, what is opposite side? NP. NP by hypotenuse is what? OP. OP is nothing but what it is? Radius. That is, I am showing here R. You can take capital R, so you can take, no problem. Then what, right? Sin theta is equals to NB value is Y, and OB is what? R. That implies Y is equals to R sin theta. Theta means what? Omega t. Therefore, Y is equals to R sin omega t. Theta means what? Omega t. So children, this is the expression for now displacement. What is displacement? Clear? Theta is angular displacement, Y is the displacement. Okay, clear, children. Now in the same manner, we have to find out now expression for velocity. Clear? What we know, velocity is nothing but rate of change of displacement. Rate of change of displacement is what we call velocity. That's why here we have to write V is equals to d by dt of y. What is R sin omega t. Here R is the constant. That's why there is no differentiation for radius vector. Therefore, what write? V is equals to what, right? R of d by dt of sin omega t. Clear, children? So what we know, d by dx of sin nx is what? Cos nx and n. This is the differentiation of sin 1. Then what, right? Here V is equals to what, right, children? R of s cos omega t and omega. So V is equals to R omega cos omega t. Clear? So we are writing simply V is equals to omega of R cos omega t. This is the formula for velocity. Formula for velocity, children. Now we need some space. That's why I am erasing this one, children. Here, watch very carefully. This is the important one. Children, for example, we are saying now it is the equation number 1. Equation number 1. From the equation number 1, what, right? Sin omega is equals to what, right, children? From equation number 1, sin omega t is equals to s. From equation number 1. From equation number 1, what, right? Y is equals to r sin omega t. Sin omega t means what? Sin omega t is equals to y by r. Y by r, children. Clear? So in the same manner here, what we know the formula? Sin square theta plus cos square theta is equals to 1. And from that, what, right? Cos square theta is equals to 1 minus sin square theta. 1 minus sin square theta. Clear? So cos square theta is equals to 1 minus sin square theta. So cos square theta is equals to 1 minus sin theta value is what? Y by r. Y by r. Clear? Then what, right, children? This is what? Y by r all square. Clear? From that, what, right? Cos theta is equals to under root of 1 minus y by r whole square. This is the value for cos theta. So then obviously what we know, V is equals to r omega cos omega t is there. Instead of cos omega t, what, right? Under root of 1 minus y by r whole square you can write. So that is the another form of expression for velocity. What it is, children? So simply here, what, right? You have to substitute this cos theta value in cos omega t. Theta is nothing but what is omega t. That's why no need to confuse. V is equals to omega r into cos omega value is what? Under root of 1 minus y by r whole square. Then what you get? V is equals to omega r into under root of r square minus y square by r square. Clear, children? So from that what V is equals to omega r of, we can write under root of r square minus square by r cancel. Then what do you get? V is equals to omega of under root of r square minus y square. This is the another form of expression for velocity. V is equals to omega of r square minus y square. Children, you have to observe this one. If you can consider the radius is some r, we will get this is the r. If you can take radius is capital A, we will get a square minus y square. Clear? So based upon the derivation we are taking, V is equals to omega of under root of r square minus omega square. Here r is the radius of the circle what we have taken. Children, so this is about the simply about the velocity expression and displacement expression. Clear? Now let's go for acceleration. Children, now expression for acceleration. So what we know, children, acceleration is nothing but rate of change of velocity. What is called rate of change of velocity. Clear? So already what we got velocity, look here, r omega cos omega t. Clear? So here r is constant, then what I simply r omega d by dt of cos omega t we can write. So children, we know that d by dx of cos nx is equals to minus sin nx n. This is the formula we are going to substitute or use here. A is equals to r omega into, instead of cos omega t what write? Minus sin omega t into omega. Then what we get? A is equals to minus r omega into omega square sin omega t. And A is equals to what, right? Minus omega square into r sin omega t. So this is the expression for now acceleration, children. So A is equals to minus omega square r sin omega t. So already what we know that since y is equals to r sin omega t, then what we get? A is equals to minus omega square into y. So when omega is constant, what, right? A is proportional to minus y. So this is the condition for simple harmonic motion. A is equals to minus omega square y, or A is proportional to minus y. It is the condition for simple harmonic oscillation. That's why, children, what we can prove that when a particle is moving along a circular path of radius r, then if we can consider the motion of the particle with respect of two perpendicular diameters, that is the combination of simple harmonic motion along the two diameters, that should be used the circular motion of a particle. Okay, that's why we put that while the particle is moving along a circular path, its motion is simple harmonic motion. A is proportional to minus y. So children, this is about the expression for velocity, displacement and acceleration. So I hope you understand. If you can understand this one, like, share, comment the video and subscribe my channel. My request is, children, you can share our channel to your friends also. I hope that this channel will help to your friends also. Okay, got it? Thank you for watching.